Okay, talk today is another relativity mistake by Brian Cox. Brian Cox makes another relativity mistake and tries to bluff it off as nuances and technical. The fact is, he made a statement about relativity in relationship to quantum mechanics, and he subsequently finds out he does not really know if that statement is true or not. It's an example of these Einstein-believers making another false claim. It's the sort of thing they do. As pointed out in my previous videos, they make false claims. Physics is being misrepresented by these believers in Einstein. What they do is say from one to another some unsubstantiated claim, and it passes down among them like Chinese whispers. And Brian Cox is going to use words like nuance to try and bluff his way out of problems he created by making statements that are incorrect, and then he's going to admit that this is how physics is taught, which is terrible. It is effectively lying to physics students by glossing over nuances because they are not being told all the facts accurately. Loose talking is being used to try to cover up the mess Einstein made. So the place I'm going to is this link here, when Brian Cox was in conversation to Robin Williams, and here we go. Start.
I am Brian Cox. I'm a professor of particle physics at the University of Manchester. And you got the full title, the Royal Society University Research.
No, I've got that already.
The new book is Wonders of Life.
Wonders of Life, and the book that came out in Penguin is
that's the quantum universe.
The quantum
universe.
Yeah, everything
that can happen does happen, which is actually a statement of Feynman's approach to quantum mechanics.
Okay, let me ask you about that very title. Is it true that everything that can happen does happen?
Yeah, in a technical sense, what you do, you ask the question, which is all that quantum mechanics tells you, really, is that I have a particle here at one point, and I want to know the probability of it being over here at the next point.
So basically what he's talking about is quantum mechanics, and I'm concentrating on criticising things about relativity from these physicists, so I'm not concerned with attacking relativity too much. But he builds up from quantum mechanics, and then he's going to bring in the relativity things, and that's when he's going to mess things up. So we've got to leave him for why as he talks about quantum mechanics.
Which is all that quantum mechanics tells you, really, is that I have a particle here at one point, and I want to know the probability of it being over here at the next point. What do you do? Well, technically what you do is you add up a quantity, it's called the action actually, but it doesn't matter what it is. You basically consider the particle moving every possible path from A to B. And Feynman's approach is to do that mathematically. So add up a set of quantities for each possible way something can get from one place to the other, and you get the probability out in the end that it will actually be in the vicinity of that point at some future time. So it's a statement of sort of technical fact in a way about how you do calculations in quantum theory.
Yes, but of course the public will immediately infer that everything that can happen in the world does happen.
Well, I'm a member, I think, of this Shut Up and Calculate school of physics. Where
So that's an interesting comment. It's the Shut Up and Calculate school of physics, so I'm going to go to that. So this is from Wikipedia. Wikipedia gives you a rough idea of things. It's not entirely accurate, but it gives you a rough idea. And what they got with quantum mechanics is they've got various interpretations. The main one seems to be the Copenhagen interpretation. If we go down in this article, it's going to get to the shut up and calculate statement. So this bit here. There we go, that bit. Many physicists have subscribed to the instrumentalist interpretation of quantum mechanics, a position often often equated with eschewing all interpretation. It is summarised by the sentence, "Shut up and calculate." That's what Brian Cox just said. While this slogan is sometimes attributed to Paul Dirac or Richard Feynman, it seems to be due to David Merman. So what you got with physicists is, with this belief, what they call "shut up and calculate," they've got this maths and they've got the theory, and they don't really know how to interpret the theory. They can come up with lots of different interpretations, and so these sort of physicists are getting fed up with trying all the different interpretations of what the theory might mean, and so they go for an instrumentalist interpretation. They're just doing the experiment with their instruments, making their measurements and equating it to the maths of the quantum mechanics, and then that's it. That's all they're concerned with. They're not wanting to interpret what that means. So we go back to now to Brian Cox and pick it up from where he's saying about that.
In the world does happen.
Well, calculations in quantum theory.
Yes, but of course the public will immediately infer that everything that can happen in the world does happen.
Again.
Well, I'm a member, I think, of this "shut up and calculate" school of physics, where quantum mechanics works. It's the way we design transistors, etc. It is our best explanation of everything in the universe other than gravity. The problem with the theory, in an interpretive sense, is that you ask the question, well, so we accept the fact that atoms behave in a strange way. And also the theory does tell you how classical behaviour, so the behaviour of cups and things and people, how that emerges from the theory. But you still have this problem that when you try to interpret it as a theory of big things, then you get these Schrodinger's cat type problems where things are indeed, everything that can happen is happening. Cats can be alive and dead, people can be in an infinite number of places.
So we could pick up on there. So as well as having the maths and such forth of theory, you've got the interpretation problem with quantum mechanics, and you get in this problem with, say, which is highlighted by things like the Schrodinger cat, where this cat in the thought experiment is well, in normal world you think of a cat would be either be dead or the cat would be alive, but the way quantum mechanics treats things, it treats it as the cat is not in a state of dead or alive. It's sort of like in a superposition thing. It's not in a defined state of whether it's dead or alive, and so it's kind of all what that's supposed to mean. It doesn't kind of mysterious how to interpret that.
Indeed, everything that can happen is happening. Cats can be alive and dead. People can be in an infinite number of places at once, and so it's how you interpret
people
that.
can be in an infinite number of places at once. So this is the sort of thing you're getting from quantum mechanics. How are you supposed to deal with a theory? It's got the maths for that, and then it's how do you interpret it.
Dead people can be in an infinite number of places at once, and so it's how you interpret that. I think that the problem really is it's a probabilistic theory. So it's telling you about the probability that things will happen. And if you think
That's his sort of point of view, that it's a probabilistic theory, and it's telling you about the probability of things. But you still got to understand what is a probabilistic theory? How do you interpret that?
Think about it. How do you interpret that? What does it mean to say, well, there's a 50% chance it's going to be here? But you might say, well, no, but it is there, isn't it? Well, no, it isn't. There's a 50% chance it's going to be there. That's how the theory works.
Yeah, I must say I found entanglement, which you deal with in that book.
So I'll get distracted by his hand signals here, his body language. He's got his hand on his chin. So why does he suddenly do that? And so I got distracted into that. And what we've got here on this website is doing about body language, about the chin movement. When you've got your chin like that, it seems to be it's a protective pose. It goes back to primitive times when you're trying to protect your chin when you're being attacked, or it could be if you're stroking your chin, you're trying to indicate that you're thinking hard about something. So it's strange that he should take that body language. It's kind of like he doesn't really understand what he's talking about, and that chin, his hand over his chin, is indicating that. something mysterious to think about. How do you interpret quantum mechanics?
Oh, it isn't. There's a 50% chance it's going to go. That's how the theory works.
Yeah, I must say I
Um,
found
so-
entanglement, which you deal with in that book, of something splitting and being here and there, and here could be, I don't know, light years away from there, and yet there are, in some ways, they are still unified.
Yeah, well, actually, it's very interesting, actually, because in the book, we do what's called non-relativistic quantum mechanics. And then it's absolutely true.
The important thing there he's talking about is there's a non-relativistic quantum mechanics. And so in non-relativistic quantum mechanics, you haven't got the problems with special relativity. And so they have other versions where you sort of like, you've added special relativity to quantum mechanics to come up with a theory called quantum field theory. So basically, in quantum mechanics, non-relativistic quantum mechanics, you haven't got all the nonsense which Einstein's given us. And it's sort of what I'm complaining about is when you're adding all the nonsense which Einstein talks about to quantum mechanics. You could go off in the direction of complaining about non-relativistic quantum mechanics itself, but my focus is upon the relativity bit. When I've done all my studies of Einstein's relativity, if I go back to my videos. This one. When you look at it, you got people like this. G. Bernstein Brown has written an article on what is wrong with relativity, and he points out it's nonsensical, the things that Einstein's doing with the maths and so forth. And a lot of people come to that conclusion that the maths doesn't really make much sense with Einstein's special relativity. So if we go then, I've got another one. Yeah, this is a video I got here. This is an example. You go through the maths, some of the maths and special relativity, and it doesn't really make any sense. You go through it and it's nonsense. And you've got other things here. Yeah, here we go. That what he's talking about. Yeah, and we've got this one here where Dr. Edward Teller points out that Einstein gave electron relativity, and Einstein didn't know what he was talking about. So from special relativity and general relativity as well, if we go on to the what's pointed out by the Roger Wyden, all this special and general relativity is coming from a person who doesn't really know what he's talking about. So if I point out this one, Roger Wyden's talk, he looked at the maths of Einstein's general relativity, and it's a long, complicated process, takes a lot of getting into, but when you go through it all, what you get is nonsense. And he says at the end, it's nonsense, it's nonsense. So what you're getting from all these people who are believing in Einstein's relativity, a lot of these claims about relativity, and when you take the effort of studying these claims, you find out what they're saying is nonsense. So if we go back to here, go back to a talk by Brian Cox. So putting aside the issue of all the complications with quantum mechanics, it's when you start adding special relativity to it, it's being built upon nonsense really. So if we pick it up again, this non-relativistic quantum mechanics.
Away from there, and yet, and yet there are, in some ways, they are still unified.
Yeah, well, actually, it's very interesting, actually, because in the book, we do what's called non-relativistic quantum mechanics. And then it's absolutely true. If you say, if I put a particle...
And that's a bad word there, saying it's absolutely true. So what he really means is that in the context of that theory of non-relativistic quantum mechanics, he's going to tell you something which is supposed to be true within the context of that theory. Meaning you've got that theory, and then you're supposed to just say put it to an experimental test, and so it's not absolutely true until you actually tested it.
It's very interesting, actually, because in the book, we do what's called non-relativistic quantum mechanics. And then it's absolutely true. If you say, if I put a particle at a point, so technically there, I know exactly where it is, where is it at the next instant? The answer is anywhere in the universe with equal probability. So there's no regard for relativity at all in this.
In other words, no regard for relativity at all. I no regard for special relativity at all. In non-relativistic quantum mechanics, you're not considering special relativity, and so there's none of this speed limit things imposed upon it. And so, from my point of view, that's just considering the Einstein's relativity bit, that is a pure theory. You've got a theory without the corruption of Einstein's relativity, special relativity being added to it, when it's non-relativistic quantum mechanics.
Where is it at the next instant? The answer is anywhere in the universe with equal probability. So there's no regard for relativity at all in this theory. It seems odd, because relativity tells us that influences can't travel faster than the speed of light.
Well, that is sort of the theory. When I've gone into it, it seems to be very vague as to what that's supposed to mean. When I go back to my videos, you've got this. Really, it seems to be. If we get to that one there, it's all really just a lie upon which Einstein's special relativity is built. So he's saying that. So it's all just a lie from what we can study from special relativity. So you've got this pure form of theory, non-relativistic quantum mechanics, and then you're adding special relativity to it, and then special relativity is just built on a lie.
It's anywhere in the universe with equal probability. So there's no regard for relativity at all in this theory. It seems odd, because relativity tells us that influences can't travel faster than the speed of light. So there should be some restriction. Now, in quantum field theory, which is the relativistic version of this, there is a modification, a quite severe modification to that.
Where you're adding special relativity to quantum mechanics, or trying to. It's still a bit of a bodge.
Version of this. There is a modification, a quite severe modification to that, but still, there's an apparent violation of the spirit of Einstein's theory.
Apparent violation of the spirit of Einstein. So this is very bluffable, isn't it? The word spirit, that implies something like something almost a new agey sort of thing. And what you've got is people like this, and they've got a very strong belief in Einstein. And so when you've got maths or theory and so forth, they still want to try to fit it into what Einstein, they think what Einstein believes. They're trying to fit it into what they think Einstein believes. And so the spirit of Einstein is sort of like, well, we want this bit of theory to fit in with what Einstein believes, what they think what Einstein believes. When you go in to look at Einstein, you find he changes his mind a lot. So it's all under delusions by these people about what Einstein believes.
To that. But still, there's an apparent violation of the spirit of Einstein's relativity. Things instantaneously seem to shift.
Instantaneously, so that is violating Einstein's what they believe about Einstein, about the speed of light. So you got something happening there faster than the speed of light, even when you're trying to add special relativity to non-relativistic quantum mechanics, and they're making it into a theory of quantum field theory. It's still not working properly.
One example of this is something called the EPR paradox, which bothered Einstein a lot.
Einstein didn't like EPR paradox, it's just another thing. And the reason why he doesn't like that is because it's violating his theory of special relativity, things like that. So
instantaneously seem to shift. One example of this is something called the EPR paradox, which bothered Einstein a lot. And actually, a physicist, so we'd said this in the book, and I also said this in some interviews, and a physicist called Sean Carroll, who's an excellent physicist over on the west coast of America. I think he's at Stanford, I think. And he questioned this. He said, no, I don't...
So they've made these claims in this book about the EPR paradox, and with the special relativity thing, so this is combining the quantum mechanics and the special relativity, and it's the special relativity bit I'm complaining about. There's problems with quantum mechanics, but it's too much to go in all these different directions, so I'm concentrating on the claim he's made in the book.
Sean Carroll is an excellent physicist over on the west coast of America. I think he's at Stanford. I think he questioned this. He said, "No, I don't believe that. I think you're misrepresenting the theory because I."
So, on to this now. The claim is that he is misrepresenting the theory of special relativity in Einstein. So, normally if a person said this to him and he didn't respect the person who was telling him this, he would just ignore that sort of criticism. But it's a criticism coming from a person that he respects, another physicist who he respects. So he's a bit upset. He's made a claim in a book about combining special relativity to quantum mechanics, and a physicist he respects has criticised him, saying you're misrepresenting Einstein, and so it's worried him a bit now.
He's an excellent physicist over on the west coast of America. I think he's at Stanford. And he questioned this. He said, "No, I don't believe that. I think you're misrepresenting the theory because I think that it surely is the case that relativity is respected." So we thought, okay, we'll prove it. We think.
So suddenly they've made this claim in a book. They've written it, the book's published and so forth, and now suddenly they decided to check the claim they've made. So you think they would have should have checked the claims they were going to make in the book before actually writing them down. No, but they don't do it that way. They've just gone. The way I see it, there's a whole chain of these people of believing in Einstein, and they've all said something. This person back further along, they've all said something, and it's all come down as a line of people saying da 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 da, Chinese whisperers, all the way down. So the long line of them have been saying this sort of thing, and it's come down to him, and it's a claim which he hasn't checked, but now he's put in his book, and now suddenly, somebody who I respect is querying what I've said, so I check my claim now. Whereas before he was just relying on what these other people were telling him. It's a long line of unsubstantiated claims, and this is what we find with people who believe in Einstein. They just make long lines of unsubstantiated claims. If we go on here, so when I've looked at the foundation of Einstein's special relativity, it's all built upon unsubstantiated claims. It's basically just built on a lie. And we go back, and people who go into the effort of actually looking at these claims, it takes a great deal of effort to go into it. They make claims about general relativity, these people believe in Einstein, and it takes a lot of effort to actually look into these sort of claims, and when you go in and look into the claims they make, you find they're false. And it's just a long tradition of these people believing in Einstein, and they're making false claims. So Brian Cox, going by what other people who believed in Einstein have told him, has put this claim in a book, and he suddenly, this claim might not be right, but that's the way they work. They just have unsubstantiated claims. That's what's going to be revealed now.
Representing the theory because I think that it surely is the case that relativity is respected. So we thought, okay, we'll prove it. We think that the book's right. It's technically right, but
this is the big word. Technically right. What's that supposed to mean? They think the claim they put in the book is technically right, and I think that's just a big bluff. It's it's what people have told him. It's what a teacher in Einstein's relativity has told him, and that teacher has been told by somebody else, and by somebody else, and somebody else. So it's a long chain of these people believing in Einstein's relativity, having this unsubstantiated claim, and it's just passed down to him from this long chain of people. and now suddenly he thinks, or what I've said in the book is technically correct because I'm going by what all these other people told me who believed in Einstein. And so no, it's just an unsubstantiated claim. It's Chinese whispers.
So we thought, okay, we'll prove it. We
Bluff.
think that the book's right. It's technically right,
Bluff.
but in spirit, is it right? And we couldn't prove it.
Couldn't prove it. So they made a claim in a book, and he couldn't prove it. He decided to check the claim, and he can't prove it. And that's how bad it is. That's how bad these Einstein believers are. They make an unsubstantiated claim, and if you're a dissident and you're saying no, it's an unsubstantiated claim, they'll just ignore you. But if it's somebody they respect, and they then decide, well, look at that claim, they then find out they can't prove it. They can't prove it. And it's just typical what they do, the Einstein believers. They make up claims and they're not true.
We'll prove it. We
They're not
think
true.
that the book's right. It's technically right, but in spirit, is it right? And we couldn't prove it. So my friend Jeff Forshaw, as a theoretical physicist, couldn't do the integral. It's a technical.
Couldn't do the integral, so he can't do the maths for it. Can't do the maths.
Theoretical physicists couldn't do the integral. It's a technical problem. And so we thought, okay, so someone must have proved this. Maybe we were wrong, but someone. And we look back, and then Feynman had actually done some work on this in the early days, and he couldn't do it either.
Feynman couldn't do it either. So what you've got is unsubstantiated claim from all these people who believe in Einstein, and when you try to get down to the issue of proving that claim, they haven't got any proof for it. There's nothing. You've got even the big people big name like Feynman who couldn't do it. And that's how bad they are. They like making unsubstantiated claims.
Feynman had actually done some work on this in the early days, and he couldn't do it either, because you can't do the integrals, they're too hard.
Feynman can't do it.
But now, it actually turns out to be a very interesting problem.
It turns out to be an interesting problem. An interesting problem. He's put a claim in a book, and now he's decided to look at that claim in more detail, and there's no evidence for it. There's nothing there. It's unsubstantiated claim. Now suddenly he thinks that's an interesting problem. You shouldn't really be making unsubstantiated claims.
So it actually turns out to be a very interesting problem. So I don't know, actually.
I don't know, he's saying. He doesn't know. So he's made a claim in a book, and now he's admitting he doesn't know if it's true or not. What a load.
So I don't know, actually, at the moment. What I'm doing is we've started a research project, which is the interesting thing, based on this popular book. And I'm writing code at the moment, because I think you can do these integrals now with computers. Yeah. But back in the old foundational days, in the 60s and 70s,
So back in the old days, they didn't have these computers to actually check a claim like that. So when this claim was made up, it was an unsubstantiated claim, and they didn't have the computers to actually check it. And now he's so going to research it to find out whether that claim is true or not. And our dissidents, when we look at things like that, they just make a mess of it. Here we go. When we look at the maths they're using, these people who believe in Einstein, they make all their maths, and the main process they use is cuckoo. So if he's going to try to make it agree with Einstein, he's going to have to use what is a cuckoo process. So how far is he going to go with it?
But what I'm doing is we've started a research project, which is the interesting thing, based on this popular book. And I'm writing code at the moment, because I think you can do these integrals now with computers. Yeah. But back in the old foundational days, in the 60s and 70s, there's kind of... everyone's fairly sure that everything works out, but no one's actually shown precisely how it works out.
Fairly sure everything works out. It's an unsubstantiated claim. It's all based on faith. Faith. You make an unsubstantiated claim and just want to believe it. because it ties into Einstein. You think it ties into Einstein. It's based upon your belief on Einstein, so you want to believe it on faith.
Days in the 60s and 70s, there's kind of everyone's fairly sure that everything works out, but no one's actually sure.
The believers in Einstein.
So it's actually quite an interesting problem. So it may be that statement, everything that can happen does happen. It may be that in relativistic quantum field theory, it should be watered down.
Watered down. So you've made a claim in a book, and you're thinking about it now, and you're worrying about it, and you realise it was an unsubstantiated claim, and now you think you're watering it down, which basically means it was wrong. If you think it's watering it down, that means you made a false claim. These Einstein believers, they're cracked up.
It may be that in relativistic quantum field theory, it should be watered down somewhat, but actually, I don't know.
And he's back to it. I don't know. He doesn't know. So back to the claim. He's made a claim and he doesn't know, and it's all come down to him from other Einstein believers. So that's what we're up against. These people who've got their faith in Einstein, and they've make claims which are false.
Somewhat. But actually, I don't know at the moment. So it's a very interesting. But I think it's an interesting example of how you teach, or you simplify something for a book, and you say something which is.
Well, an example of how you teach, and you simplify something, and you simplify it for the book. You've made a false claim. You've got an unsubstantiated claim, and you put it into a book, and you're teaching physics students unsubstantiated claims. And that is supposed to be good. That is teaching them things that are false. You've got to be more accurate when you're doing physics and science. You can't suddenly make up stuff, and that's unfortunately what the people who believe in Einstein have been doing. They've been making up unsubstantiated claims.
But actually, I don't know at the moment. So it's a very interesting. But I think it's an interesting example of how you teach, or you simplify something for a book, and you say something which is technically correct as far as you can.
Technically correct again. And what does he mean by technically correct? It's just that Chinese whispers. It's only because other people who believed in Einstein have all said this sort of thing, and they've all said this unsubstantiated claim.
Example of how you teach, or you simplify
Bad
something
example.
for a book, and you say something which is technically correct as far as you can tell, but there's a lot of nuance.
A lot of nuance. So he's bluffing now. As we go to nuance. Nuance. There's a definition of nuance from the dictionary. A subtle difference or distinction in expression, meaning, response, etc. So he hasn't given a completely factual statement, and there's nuances. He needs to be more accurate. People who believe in Einstein have not been very accurate in what they've said, and they've got all these subtle little nuances, all the things they're missing out saying, and so their facts are distorted. They're not right. They're just wrong, basically. You tell a student a supposed fact, you miss out telling him the nuances, you basically lie to them, and that's basically the education system.
So it's a very interesting. But I think it's an interesting example of how you teach, or you simplify
Corrupted
something
teaching.
for a book, and you say something which is technically correct as far as you can tell, but there's a lot of nuance in there actually, which we're still investigating. So
you said popular book, there's lots of nuance, but also there are several equations, and that's probably the most technical of your books. How did it go with the public?
Well, it's done very well. It actually, the response tends to be split. If you look on Amazon, for example, or you look at the comments on some book site, then there are people that love it because it does explain the theory, and it does do.
It doesn't explain the theory. If you made statements and those facts aren't accurate, they've got subtle, what you call subtle nuances. That means you've distorted the facts. They're not. It's not accurate. It's not an accurate statement. Not an accurate book. People who've read it, they've just been fooled. They believe things which are false, And if you taught those sort of things, people have believed things that are false. It's not good. Right, so I think that's basically it for the talk, really. He does go on to more details. He goes on to things like the Higgs boson. He talks about science and comedy and so forth. But that's the main thing. He's done it, made a false claim in his book. He's now checked that claim, and he finds he can't prove it, and he suddenly has to do a research program to look into it. And so this is typical of the example of what these people are like. They just make unsubstantiated claims, and it takes a great deal of effort to look into their claims and find out they're false, and which is pointed out in my videos. Us dissidents have looked at their claims and they were false. We've looked at special relativity, we looked at general relativity, and they're just making up false claims. It's a process of nonsense. They think they're being clever, and they're just talking nonsense. So we go back. There you go. I'm going to go into my video here. My video here, I make out that saying what Einstein's talking about is nonsense is a valid conclusion. Saying Einstein's talking nonsense is a valid conclusion. So you read Einstein's relativity, you read what other people have said about relativity, you then form a conclusion what it all means, and decide it's nonsense. That is a valid conclusion. But sort of like the people like the Einstein-believers, people like this, they make their unsubstantiated claims and they want to believe in Einstein, so it becomes kind of like a religion to them. And so if somebody says, oh, Einstein's just talking that nonsense, well, they don't recognise that as a valid conclusion. They want to go and believe something like, oh, the person who said that didn't really understand it. No, we've looked at Einstein, we understand what Einstein's saying. We understand what he's saying is nonsense. Einstein has changed his mind a lot about things. One minute he said one thing, and next minute he said something else. And sort of like when he formed his special theory of relativity, he was working from one philosophy, and then later on in general relativity he had a different philosophy. So it's never been clear as to what any of that is supposed to mean, changing your philosophy. So you've got this fundamental problem of trying to understand what Einstein is talking about, and he's left it all confused because of his change of mind. So come to the conclusion that Einstein's talking nonsense is a valid conclusion. They want to believe in something and keep bodging it. So that's my basic ending, I think. I'll pick anything else up. That's the link for Shut Up and Calculate, and that's a link for Spooky Action, and I go to that Spooky Action just to bring everything up together. That one. So this is quantum entanglement. So quantum entanglement. If we go down, find Einstein. Fine. And next one's more. And this is what it is about. Entanglement. Einstein referred to it as spooky action at a distance, so he didn't like it. It seemed to violate his special relativity, so he didn't like it. This is the thing. Phenomenon entanglement. He didn't like it. And they're trying to bluff it. They're trying to keep it going. They're trying to keep special relativity going, even though it's violating things. They're making their claims in their books, and they're unsubstantiated claims, and they're just thinking it's nuances. Well, it's just covering up the mess. Thank you.